Okay, so this is a basic elevator problem. We're trying to find the apparent weight. So let's pretend the elevator is moving up at 2 meters per second squared, so it's accelerating. That's its acceleration. And that this guy weighs, his mass is 40 kilograms. And that's all I know. And I want to find out his apparent weight. Okay. So to start off, I would start off by figuring out all the forces on our little guy. If the elevator is accelerating at 2 meters per second squared, that means the guy is also accelerating at 2 meters per second squared. And the forces acting on him is the force of gravity pushing him down, right? Because there's a force of gravity here. And there's a normal force pushing him up because he's on the ground. That's the ground of the elevator. Apparent weight is pretty much asking me to find out what the normal force is. Okay? So his force of gravity is always equal to his mass times his gravity. Which is equal to his mass, which we know is 40 kilograms, times gravity, which is 9.81, which would equal 392.4 newtons. So we use our net force, right? The net force, let's use a different color. We lost this. Not sure what happened here. That equals 392. So let's do this with a different color then. So our net force, if we just look at the y, is equal to the mass times the acceleration in the y, which is also equal to all the forces in the y added together. The only forces in the y that we're looking at is the normal force pushing up minus the force of gravity, because it's negative, because the force of gravity is going down. So we get, if we plug in our variables, we know what his mass is, we know what his acceleration is, right? His acceleration is 2 meters per second squared. His mass is 40 kilograms. So we get 40 times 2 equals his normal force, which we don't know, minus his force of gravity, which is 392.4 newtons. So we get 80 So we add 392.4 to both sides, and we get 472.4. Equals the normal force. Done. That's gonna be his apparent weight. His real weight is 392.4. That's his real weight. His real weight will always be mass times gravity, but because the elevator is moving, it would appear that his apparent weight is 472.4 newtons. Keep in mind that the 2 here was positive because the acceleration was going up. And in the next problem, we're going to make his acceleration go down, which is the only thing that changes, is that this number here would become negative if we were moving down.